Now let's learn the coherence, interference, and diffraction of light. Let's first start with the phase difference. Assume we have a wave like this and another wave which is completely overlapping with the first one is said to be in phase. These two light waves are in phase. Why? Because their crests and their throws are at the same point. But if you have such two waves, as you see, the first one, the green one, and the red one, this is the crest of the green wave and this is the throw of the red wave, and these two waves are not in phase. They are completely out of the phase. Why? Because as you see, if this is, for example, timeline t, first this one becomes maximum, it peaks the first, and then this one peaks the first. So there is a difference between them, and this difference is called the phase difference. So these two waves are out of phase. Similarly, these two waves are also out of phase because initially this one peaks and then this one peaks. This is not completely out of phase, but they are out of phase. So let's continue with the monochromatic light. What does monochromatic light mean? The monochromatic describes light that has the same wavelength, so it is one color. A light of one color is a monochromatic light. What about the coherence? The coherence is the light in which all the electromagnetic waves have the same phase, direction, and amplitude. Let's go into the details of the coherent light. Now assume these waves. As you see, these waves have same wavelength, same frequency and amplitude. Look at the amplitude of this wave. It is approximately, this is the amplitude of this wave, and this is the amplitude of the second wave. This is the amplitude of the third wave. So they have the same amplitude, wavelength, and frequency, and they are also in phase. As you see, their crests coincide. Their throws are also coinciding. So that's why this is called a coherent light. And this is also, it is both coherent and monochromatic because same wavelength means same color. And since they are in phase, it is called coherent and monochromatic light. What is the difference between the monochromatic and coherent light with non-coherent light? Now this light, as you see, it has a constant wavelength. Here is the wavelength of the first one, and this is the wavelength of the second one. This is the wavelength of second one. Their wavelengths are the same, lambda and lambda, but they are not in phase. If they are not in phase, it means this is not a coherent light. So this is a monochromatic light, but not coherent. It is incoherent. The wavelength is the same, frequency is the same, amplitude is the same, but it is not in phase. That's why it is called monochromatic, but not coherent. This type of light is the LED light. It is light emitting diodes, and this type of light is the light of the lasers. And let's look at another type of the waves, I mean the light. So in this case, the wavelengths are different from each other. The wavelength of the red color, the green color, blue color, they are different from each other. Their frequencies, their amplitudes may be equal or different from each other, and also they are not in phase. So this type of light is the sunlight, and it is non-monochromatic, and also it is incoherent. Let's look at the interference of light. What does interference mean? When waves of the same frequency combine to reinforce or cancel each other, the amplitude of the resulting wave becomes equal to the sum of the amplitudes of the combining waves. For example, look at this wave. And if you have another wave, these two waves, when they overlap, they are going to combine and they have their each amplitudes. But once they overlap and they combine each other, the new amplitude becomes the sum of the two amplitudes. If this is y1, the amplitude of this one is y1 and the amplitude of this one is y2. In this case, this amplitude will be y1 plus y2. In this case, these are called constructive interference. For the constructive interference, as you see, the two waves are in phase. Their crests and their throws coincide. That's why they are in phase, and this type of interference is called constructive interference. On the other hand, if they are out of phase, two light waves, when they are out of phase, one of the crest, this is the crest of the first one and this is the throw of the first one, these two waves are completely out of phase. When they meet, when they overlap, when they meet each other, they completely destroy each other, and this is called destructive interference, and the light is going to be, the wave is going to be a straight line. What about the diffraction of the light? When light is propagating, these are the wavefronts toward a slit. Okay, when the light passes through a slit, it is slightly bending. The bending of the light is called diffraction. So the diffraction is the slight bending of light as it passes through a slit. The amount of bending depends on the relative size of the wavelength of light to the size of the opening. So when this opening is big enough, if it is big enough, if the opening, if the D is bigger than the, for example, wavelength of the light, this is the wavelength of the light, if D is bigger than wavelength, much more bigger than the wavelength, in this case, no diffraction take place. So they must be approximately equal to each other for the diffraction to occur. Interference of light is, okay, let's look at wavefronts propagating toward that side. The light is propagating toward right, and if we put an obstacle in front of the propagating light, here we have an obstacle, but also we have two slits. This is one slit and this is another slit. Now light is going to pass through these two slits. When light passes through the slits, it is bending. Remember the diffraction of the light. Diffraction will take place, it will take place both here and here. So this is going to be the light waves from this slit and also from this slit. And here, as you see, light is spreading from this slit, and also light is spreading the second slit, and the lights from the two sources, this one is a source and this one is another source, the light from both sources interfere. At some points they construct each other, for example at this point. Okay, so at some other points they distract each other. If we put a screen here, this propagating light, this is the light incident light passing through two slits, they interfere, and on the wall or on the screen we are going to see a diffraction, we are going to see an interference pattern, and at the middle we are going to see a bright region, then dark region, bright region, dark region, and we are going to see a series of dark and bright fringes on the wall. So when we have bright fringes and when we have dark fringes, so the light from this opening and from this opening, as you see, they are traveling through a point. For example, they are traveling through from this one to here, this point, and from here also to the same point. Okay, as you see, when the lights reach to this point, if they overlap, if they construct each other, if they interfere they constructively interfere with each other, they are going to reinforce each other, and here we are going to see a bright point. On the other hand, if we have two waves from this source, also, and when they come to the screen, once they are out of phase, they are going to destroy each other, and at that point we are going to see a dark point. So on the screen we have bright and dark regions. At the bright regions, the light from this slit and from this slit, they construct each other, constructive interference happens, and here destructive interference happens. So this is the interference of the light, and as I mentioned before, for the interference of the light to take place, the slit, the width of the slit, and the wavelength of the light, this is lambda and this is the width of the slit, they must be approximately equal to each other. So what are the conditions for the interference to take place? First of all, the sources should be monochromatic. Second, the sources must be coherent. What do I mean by coherent? They must maintain a constant phase with respect to each other. For example, here, why we do not use two identical light sources? For example, can we use one light source and another light source, and on the screen, can we again have bright and dark regions? Can we have bright and dark regions on the screen if we have two light sources? For example, two red light sources. Are they going to make an interference pattern on the screen? No. Why? Because two light sources are not going to be in phase. To get two sources of the same phase, we need only one light source. The light from only one light source is approaching to these two slits, and remember from the Huygens principle, these two slits are going to behave as a source of waves, and waves are going to spread from these two slits, and they are going to act like two different but in phase sources. Then we are going to get an interference of light on the screen. That's it. Thank you for listening. See you next time.